We've been sent this LED panel to take a look at, and apparently it stopped working. It was making a loud buzzing noise, and I can't remember who sent this. Couldn't find the messages they sent regarding it, but they say extremely loud humming with vibration. There was a block connector behind the half lantern. Could a spider have caused a short? I'm not so sure. The buzzing and humming makes me wonder if it's degradation of a dropper capacitor causing the relay in this, if there is a relay in this, to buzz. So let's take a look at the LED panel first. The LED panel does not have the black spot of death. It looks fairly clean. It looks young actually. It doesn't look like it's been pushed too far. It's got a little driver here, and the driver comes onto the circuit board, and I'm seeing the first connection here comes and it goes parallel all along these LEDs and all along these LEDs, and then it kind of loops through from there. That continues on. So I'm guessing it's a group of parallel LEDs in series with another group of parallel LEDs just to make up a number. I'm not sure what voltage this specifies. It says 8 to 18 volts DC, 350 milliamps. Okay. So, based on the fact there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 LEDs in parallel, and the LEDs are numbered, it goes up to 56. That would suggest there's 4 circuits. Let's try this out with a bench power supply and see if we can get it to light. So the power supply is on. There's negative there. Trying to keep positive well away from it. Oh, it's lighting. That looks alright. Hold on, let's crank it up. Let's see what voltage it goes to for the 350 milliamps, because that's what the power supply is limiting it to. 13 volts on the button for 350 milliamps. Okay, well the LED panel's working. That's a good start. Let's take a look at the rest of the circuitry now. I'm very suspicious about this unit here. I have plugged it in, I have tried running it, it was just dead completely. So let's get the back of this off. The slightly corroded back of this, it suggests that maybe water ingress is a factor. It often is. Water gets in everywhere, either by dripping in through crevices in the case, but more likely through condensation, through thermal cycling and pulling water in, even through quite tight seals. Okay, so the sensor is using, you can see a slightly domed capacitor here. It's using a capacitive dropper. There's the relay. This capacitor here is, what's it doing? So we've got the capacitive dropper, we've got the bridge rectifier as the diodes in the back. There's no signs of corrosion inside, which is quite good. I think one of the first things we should do is test this capacitor here. A bit suspicious about that. So let's test that. It will have a discharge resistor across it. Capacitance. I'll double check where I discharge it with my fingers. That says 370 nanofarad, which actually isn't too bad. What's it supposed to be? Does it actually say? $390 nanofarads, so that's actually pretty good. I wonder if its moisture ingress has actually caused problems. The bulging capacitor is just that tiny bit suspicious, isn't it? Okay, tell you what, I'm going to check that. Just give me a moment. Right, in hindsight, given what I've just done to my meter leads and the circuit board, maybe I should have videoed that. It just went bang. It's taken a good chunk out of the meter lead. Fortunately, I've got spare meter leads. Anyway, one moment please while I see if I can recover anything from this. No, that is absolutely toast. I think I may have bridged from live onto the low voltage rail. That's a bit annoying. Okay, let's see what we can do then. Let's see if we can at least recover something from this. Damn, I should have filmed that. It was spectacular. What a bang. And it's kind of telling that, you know, it didn't even bother me when it happened. This is what happens when you work with electricity far too long. So let's see if the driver still works. I'm pretty sure the driver will still work. And it should be able to drive the LEDs directly. That's one of the slight perils of working on live electrical equipment, circuit boards like that. It's very easy to bridge between pads. I'm pretty sure that I must have gone, I was probably trying to get a good connection, and very likely to get into a good connection that I probably went too close to the live there and bridged across it. Yeah, it was good. It sounded just like all good electrical explosions should. So let's strip this back. Kind of a shame because I kind of wanted to see what was actually wrong with that. There's lots wrong with it now. Whatever fault I found now isn't guaranteed to be the original fault. It's probably the man-made one that I just put in. Could be worse. I was standing next to someone who did that with a very, very expensive control system. They managed to short the mains onto the low voltage side and took out lots and lots of very hard to replace electronics. EPROMs containing software, that's always a bad thing. So let's see what we can recover here, and if I'm right, we'll at least have a driver and an LED panel. We don't. Oh, that's interesting. So I couldn't hear the relay clicking on that unit. I'll tell you what, no. Perhaps the fuse has blown in here. Do you think the fuse may have blown in here, owing to the fact that I just shorted it out? One moment, please. Wasn't the fuse? It turned out the bench RCD had tripped, even though there was no path. Nothing had actually gone to earth. It must have just been disturbed by that sort of glitch. So the panel's working. It's fine, and the little driver's working. But this is, well, if it wasn't working before, it's definitely not working now. It's absolutely toast. Oh, I wonder. No, it's too many tracks missing. I was going to try and put a supply on across the Zener diode here. But that's not going to happen. So here, what we've got here, I can describe what it is. Let's turn this light off because it's quite irksome. There does appear to be, what I'm guessing, this capacitor here is probably part of a snubber network. It's going from the live output, the look of it, and it's coming across here to a resistor, a 150 ohm resistor, which looks as though, well, it might have at some point gone to the other connection. Yeah, that's a snubber network across the output. So that's what that was, and this is the main dropper capacitor, and there's the Zener diode that caps the voltage, that stops going up too high. The capacitor here is slightly domed, but not dramatically domed, but then any doming is worth checking out. But yeah, all a moot point now since I've blown it up.